Good afternoon, everybody. And six students have joined the class. Hopefully, in next couple of minutes, more students will be joining up. So then we will start our lecture. Okay. So good afternoon, all. And today I will talk about ECBC compliance building, and that is again a very important topic. And it is you can say it is a burning topic in India as far as energy efficiency is considered. And anybody knows that in Rajasthan, which is the first ECBC compliance building? Anybody knows? Anybody from Rajasthan? Okay. That is one building, that is Prabha Bhavan, MNIT Jaipur. That is considered to be the first building which is ECBC compliance building, and that building was actually demonstrated to be a ECBC compliance building. We all know that energy conservation building codes gives three types of compliance systems. Like one is ECBC compliance, another was ECBC plus, and then super ECBC. But around 2007, we don't have that this extensive code. At that time, there was only one thing, that is ECBC compliance for ECBC building, ECBC compliant building. That is the only thing we have. And at that time, it was felt that how to demonstrate if a building is ECBC compliant or not. That was the task. That was an Herculean task at that time, because although we were having ECBC from 2007 onwards, but no state was willing to take up as the initiative. And handful of state at that time agreed to go for ECBC compliance, and that too without any proper guidelines. They were reluctant at how the architectural fraternity or the engineering fraternity will look ECBC as such. So that was the basic problem at that time. So uh, MNIT Jaipur took up the initiative, and there was a old building known as Design Center at that time. Innovation and extension of Design Center started, and that complete thing happened to be on the guidelines of ECBC compliance. And one of your alumni from Central University of Rajasthan, Asudedani, was involved in the process. So that is our proud moment, that the report that was drafted by the committee, and that committee also include one of your alumni, Asudedani. Right now, she is, I am not exactly sure, but she was working for Griha. And I think after that, he was working for USGBC in Delhi. And so that was in the summer vacation time. And she got opportunity to work with Dr. Jyotirmay Mathur. And he is uh, say, Center for Energy Environment, MNIT Jaipur. He is the leading uh, faculty member. He is the leading person that is also involved in making up of ECBC document from Rajasthan, and you can call him A-level scientist because of his uh, work and because of his research work that we have. So most of the architects, even myself, we all get attracted towards him because of his work ethics, because of his exposure. And let's see what type of document at that time they have prepared. One of my friend, that is Asutosh Gupta, he is co-director of EDS, and he was my classmate, and he is also he his future is also carved by Professor Jyotirmay Mathur only. So let's see what type of document it is. Okay. So those who are familiar with MNIT Jaipur, I think one of student also belong to MNIT among you all, and I hope many students have visited MNIT Jaipur, and those who have seen this building. How many of you have seen this building, Prabha Bhavan? That is the
Yes, sir.
institute.
Sir, me, Kumit.
Kumit only, no,
Yes,
nobody else. So Kumit, I think you have visited this place when? I think you studied in MNIT or what?
yes, sir. I did my graduation from there. So every day or every other day was like we were visiting to
Yes,
the
yes,
CC
yes.
labs.
So I think if you were fortunate enough, have done some interaction related to Prabha Bhavan with Professor Mathur or Professor Tushchandra?
Tarush sir was our HOD, till in I think 1819. So when the building was being constructed, like renovated, so we
Hmm.
were continuously I was in first year.
Visiting.
Yes.
Yes, yes.
So earlier it was like only ground floor, and all our academics वगैरह registration वगैरह was done in that first phase. Then the building was being renovated. So we were continuously like coming along and seeing. But being a fresher, we were not much able to understand how things were
Mhm.
actually working out. But then in later years, when the building was finished, then somehow some things we could grasp, but not the entire like
Okay,
of that.
okay. Uh, so we will have a tour, and this document is there on the MNIT website. Anybody can search, anybody can type the title, Energy Conservation Building Code compliance and beyond a pilot study, MNIT Jaipur. So anybody can type on the Google and they will find this document that is free. And that this document becomes the framework for architects who are working in the field of energy. So just look at it and just we will. And this project was initiated along with the Pacific Northwest National Laboratory, and I will just read it out the important points of the executive summary so you become more aware about the situation. Ever since launch of Energy Conservation Building Code in India in the year 2007, efforts are being made to develop enabling environment for its effective implementation in the country. Due to the consistent effort of Bureau of Energy Efficiency and other bilateral projects, especially by USAID, that is supported the Eco 3 project, that is again a very famous project. Awareness about promoting energy efficiency in the building sector got onto the agenda of different governments, state governments of the country. In the year 2010, Rajasthan took up an initiative, and after following the process of forming technical committee for adapting the ECBC to the state of Rajasthan, stakeholders, consultants, and other legal processes, notifications, they were released, directives, they were released in the year 2011. Rajasthan ECBD means Energy Conservation Building Directives is not significantly different from its parent code, that is ECBC. So Rajasthan has its own ECBD, that is Energy Conservation Building Directives. They are changed little bit depending upon the climatic situation. Otherwise, they are completely that of ECBC of that time. In the year 2007, we have a single specific code that doesn't differentiate too much about multiple, you can say, levels of compliance. That was only taking one compliance, that is ECBC compliance. So ever since then, there was a constant uh, need that being felt along with the fraternity that we should have a project, live project, through which if we can demonstrate and document that this thing can be achieved and this thing is practical in nature, it is just not theoretical part. So we can dissipate this knowledge among the larger fraternity of architects and engineers. That was the prime goal, so that at least we have some framework available for architects, practicing architects to follow, or the students of architecture department, they will get the gains from the very beginning. So MNIT Jaipur, which is everybody knows is a government of India funded institute. It is one of the best NIT of India. It was established in 1963 and the architecture department was established, if I remember correctly, in the year 1988. The institute took up this fantastic task of implementing it. So they identified a design center building in which it was earlier it was a computer uh, lab kind of an area where we used to have some 200-300 computers, and all of the students we were studying in I was studying in MNIT in the year 2003 onwards. So in after 2004 onwards, we used to go to labs because we don't have internet connectivity at all at that time in the hostels and even in the uh, classrooms. So we were going to the design center to have some kind of internet connectivity to download something for our commissions and all this. And it took us a lot of time to even book a computer for us, because at that time also there were around 5,000 students, and the design center at that time may have some 500 computers, desktops. So anyways, so the constant need was felt, and there was a complete change in infrastructure. The need was felt that we will have some kind of academic area where students can sit there and have a large computer lab with say 1,500 desktops, and even the administrative area of will be again transferred to this place, because at earlier time we used to have a small administrative area, single story, that is to in around gate number 3, if I remember correctly. Yes, gate number 3. That is, now we have Center for Energy and Environment there. So all the administrative and these things were transferred to this area, and a complete new plan of a building, extension of the plan. Earlier it was a courtyard building single having a single courtyard. So I will just show you. I will open up the Google Earth and I will just show you how it has actually progressed. So wait for a while till your Google Earth is opening up. I will just share you the development at what stages it has been developed. So you can visualize this thing easily. I'm sharing up the screen. I think, are you able to see the screen?
Yes,
Yes,
sir.
sir.
Okay. So this is the MNIT campus that is located in Malviya Nagar, Jaipur. And the western side entrance is the main entrance, and this is the arterial road. So along this arterial road in the southern direction, you have this building. So there are some few things that you can, that is easily distinguishable. We have a ramp system here. See the cursor of my mouse. So this protrusion is nothing but it is related to the ramp. There is a heavy massing along the southwestern corner, and then you have a courtyard building. You have solar panels throughout the building, and you will find that solar panels are designed according to the solar geometry. Hence, the building is perfectly oriented along. Its orientation is so perfect when in terms of picking up the sun energy for the solar photovoltaic. So I won't argue that this is the best orientation in terms of solar passive architecture, but yes, this is the best orientation in terms for of gaining sun energy for the solar photovoltaic panel. So there are, it's a complete, if Qumit might be remembering the capacity uh, of this solar PV panel system. And then on the periphery, you have some air conditioning outdoor devices on this side, preferably on this side, I think, and on the western side. This is all now just you see it's when I was a student, maybe say in the year 2004. It was a kind of a building like this. Okay, yes, this is more clear. So it has a courtyard and a single story building. After that, around 2011 and 12, the construction was going on and it was completed in the year 2015 or 14 or so. So now we have this complete building. We have all the landscaping and parking going on. And this is Vivekanand Lecture Complex. And this is counted as the largest lecture complex in Asia. Almost more than 4,500 students can sit in this lecture complex. So this is the largest lecture complex in Asia. So I'm sharing the document again. Yes, I think the document is visible. So MNIT took up this, and so as soon as the ECBC was adopted by the state of Rajasthan, project of adding one floor on one of the existing single story building called Design Center, now renamed as Prabha was being initiated. Quick valuations of load revealed that the building was falling under the scope of energy conservation building directives after adding one floor. So there are at that time, if you see, if you go to the ECBC guidelines, then it is saying that it will be for commercial building, it will for institutional building of having of such and such area. If there is an addition, the building falls under the category of ECVC. So there are norms that which building need ECVC compliance. So that as per that, it was falling under that. Hence, it was selected as a candidate building for doing the pilot project. Later, through an internal decision, additions of one more floor was done or thought of. So now it has 3 floors. Decision about selection of material. Just a minute. Hello. नमस्ते. कौन सा बोल रहे? हाँ, मैं अभी क्लास में था. मैं कॉल करता हूँ. मैं आपसे कॉल कर लूँ. जी. हाँ जी, हाँ जी. हाँ जी, हाँ जी. So, decision about selection of the decision about selection of material, systems and component, etc., have been done considering the compliance process of that is the whole building performance method. Now you have to think here that there are two different type of compliance procedure for going for any compliance related to energy efficiency. One is prescriptive method, another is whole building performance method. So in prescriptive method, each and every parameter related to energy, say U values, transmittance of the glass, flow types, tiles or stones. So the thermal mass related parameters. So if even if you are using a door, what can be the type of door? So every building component will be as per the prescriptive method, means as per the specifications. So there are certain specifications given that U value of wall should not be more than this. Transmittance should be in between this range. So everything is prescribed. Doctor give you prescription. What is that? The doctor will give you a slip in which he will write or she will write the prescription that you have to take this medicine. Similarly, the prescriptive method will give you prescriptive values for all the building components. So that is how the prescriptive method works. Prescriptive method work generally is more uh, taxing to the budget, because if you follow each and every rule and regulation related to the prescriptive method, then the building cost will increase more. So 99.99% architects, engineers, firms, they follow whole building performance method because this is very easy to do, and we have facility of trade off between the component. In whole building performance method, we check how much the building energy consumption is, how much we can reduce it by implementing energy efficiency. So in the previous class, I told you about the software. These softwares are very good in evaluating that how much will be the reduction in energy if we apply certain energy efficiency measure. So even if your building has 3 4 components poorly designed, but still if you are able to show through the software that through the whole building performance software that your building is an energy efficient, the building will get compliance certificate. That is one of the reason people go for whole building performance method, because this is simple to. First thing is money is not money will be reduced. If you go for prescriptive, this is more costly. This will take more time. And in whole building performance method, you can just quickly change the energy efficiency measure, you will get the result. So you can find out the optimum result, optimum energy efficiency measure quite easily. So that is the first, that is now the first choice become all the professional. Major reason behind it was a flexibility in decision making, especially considering factors such as cost, feasibility, restrictions due to the existing floor. Increased by the energy saving potential, the pilot project of ECVC got extended to the showcase energy beyond ECVC. The result have shown that the new building with all the energy efficiency measures undertaken is likely to be 30% more efficient than the conventional building. Okay, means the conventional building, if the building is there, if we create the similar building, it will consume more. But our building, that is the ACBC compliant building, will be 30% more efficient than the conventional building. So this is what I think this is all about the project. And as far as your design is considered, this can be the some of the things can be directly reviewed from this document. Like you are designing an Indian Institute of Architect building, so some of the design strategies you can refer here, and generally this document will be for the energy simulation persons, but there is a section of some architectural parameter. I will go to that also. So what I need is you just download this document, go through this document randomly, means just take what are the headlines, what are the things that there are. It's a 40-50 page document, so you cannot read actually, because it's there are a lot of so you cannot read in 1 or 2 days. It requires a little bit of more time. So you go through the executive summary, then go through some of the important content. I will just brief you down a little bit. There is some introduction that I have already spoke at length about the project. This is the building. This is the new building now. North is upward. So one important thing, north has to be upward. This is universal, uh, you can say, agreement that north has to be on the upward direction only. So this is the one thing you have to take into consideration. I will go to, yes. So I will don't go too much about it. There is some climatic conditions given. So this is the chart that is taken from NBC 2005. Some latitude, longitude given, SDD and CDD are given. Now here you must say that for cooling degree day, the base temperature is taken up as 18 degrees Celsius, and for heating degree day, base is taken up as 18, 10 and 18. So 18 degrees Celsius for heating degree day. Uh, I may not agree with this, but they might have taken up some values. But I think for cooling degree day, they are little bit more lenient. Heating degree day, they are more stringent. So I think the better is you should go for refereed. I think logically, anything beyond 18, why we need heating? There is no need for heating degree. Sorry, for cooling degree, the base temperature of 10 degrees Celsius, I don't understand. Heating degree, the 18 is okay. After 18, you need heating. But cooling for 10 degree, there may be some misprint. This seems to be a misprint, I think. Uh, so even in the best of the best documents across India, you will find people are doing some kind of errors. So the main thing you have to take care is that your whatever your report is, it has to be impeccable. So just by looking at this is the first time I am reading this error, because I generally skip this climate condition page. Anyways, so I think it should be 20 degrees with it's a misprint. Then these are climate consultant charts, nothing more. This is wind rows. At that time, you have wind rows like this, which is not good right now. This is a 10-year-old document now, or 7-8-year-old document. Now we have better Windows diagrams in the climate consultant software. This is psychometric chart. Then the energy efficiency concept and approach, and there are four strategies, different strategies. The first one was, and the bottom most is architectural modifications, then building design, after that HVAC design and integration of renewable energy. But what happens, that architectural modifications are comparatively cheaper in nature, whereas the renewable energy are more costlier. So you have to design for all the levels. But architectural modifications are the cheapest one when you are designing a building, okay, or you are extending a building. But if you go for renovation, then it's a problem. Even in that case, architectural modifications may become more costlier in some cases. Then ECBC check and compliance route. So you go through this. I will come to the architectural component. Yes. So the one thing is the courtyard based design was uh, preferred. Means earlier there was a courtyard, so its nature was uh, you can say adopted again. So the second and the third floor, sorry, the first and the second floor, they retain the courtyard. And then vertical shading fins were added up in the building. Initially, they were not. So fins were used to curtail the the sun, the early morning sun, on the late evening sun. So in the all around the building, it has fins, but on the southern side, it provides more benefit because you want to curtail low angle sun. And then horizontal shading means there is a projection here. Below it there is a lobby. So when you are standing in the lobby, you have a large projecting room here above. So that is again a architectural parameter. Then double glazed windows are used, which has which has air or maybe argon. I don't remember exactly. Air may be the case. So DGU unit which has an air gap in between. So this is used to increase the U value of the glass. So the inside room space will be let will be inside conditions, temperature conditions remains more or less within the comfortable limits. In one of my lecture, I have taken up decrement factor. So decrement factor was again from 0 to 1. I think it was changing. So you can go to that video and just check what I am talking about. So by DGU, they are actually uh, affecting the decrement factor so that the internal inside conditions variations is not too much throughout the day. Then for cross ventilation, that is, you have window on the one face, windows on the another face. So even in the corridor areas, you will find some window in the other side. Then insulating material, it means EPS insulation kind of a thing is used specifically in the southern and the western face. In the northern face, there is no need for generally there is no need for any insulation as such. Even in the Central University of Rajasthan here, we in some of the faculty quarters, if you go for residential buildings, the western face, the southern face, and the eastern face, they have XPS insulation, 5 centimeter XPS insulation, but the northern face, they have nothing. Even in the northeast direction, they have no insulation. So the insulation is directly dependent upon the sun angle, where the sun is falling. So that is also an architectural element. Solar energy integration is there. Then energy efficient lighting fixtures, that is also you can use. Like there are uh, lux level dependent lighting fixtures are there. It means around the windows, if you have these kind of fixtures, what is happening if you have good daylight level, what is happening, the surrounding artificial lights will automatically switch off. That these type of things can be used, although this type of thing is not used in Prabha Bhavan, but yes, they are used. Energy efficient lighting and fixtures are used in the corridors of Prabha Bhavan at some extent, but other things may be incorporated with the sensor based technology. That is, you can have a lux meters lux sensor which sense if the daylight is sufficient or not in the working plane. And then if it is sensed that the lighting level is less, automatically the lighting which is close to the windows, they will function, so that the optimum daylight level can be achieved. So these type of technologies we have nowadays in most of the institutional buildings abroad, and we are in India also. Some of the 5-star Griha buildings, they are going for this type of technology. And this is the plan, and some of the other strategies, they claim that they have benefited in achieving or benefited in reducing the solar heat gain and hence the energy consumption like this. This is the ramp system they have in the western direction, and this ramp is little bit protruded from the western phase, and in the late evening it has been claimed that, and even between, say, most of the time between 3 o'clock to the 5 o'clock or 6 o'clock, the sun is not hitting this particular wall. If you just see the cursor of my mouse, this wall is not exposed to a sun that is around 3 o'clock and between 3 to 5. Office hours are between 9:30 to 6. So, and if you go, then you will find that the heat gain is maximum around 3 or 4. So if you are able to curtail down direct sun from 3 to 5 p.m., it means you are considerably reducing the solar heat gain inside the building through the windows and even through the conduction from the walls. So this particular western wall gets saved from direct exposure to the sun, and this is response. So the solar heat gain is reduced in this particular section in the northeastern block. Then if I have another map, yes, this is the first floor. Here you will see that all the uh, this is south, all the southern face, which generally have more solar exposure, specifically in the winter time. And even in the winter time, if the sun is at higher altitude angles, you don't want that sun to come into the area of working space. So say between 1 to 5 or so. Yes, early morning sun, you always welcome. That is because that is your buildings and all these, they become cool at night, so you need some exposure. So the strategy was to have all the buffer space in terms of a corridor and the staircase located in the southern direction, so that from the southern direction you don't have much of the solar heat gain, whether it is direct or through the windows or through the walls. So that has been eliminated completely. You will see like this, the complete. And then you have the facility area covering up almost 30% of the southern face. So again, all the activity area are placed inside the building. So the southern face has the lobby, staircase, toilet facilities, and so most of the areas are located here. And you only have one committee room here, which is directly exposed. So even this is a committee room which cannot function for complete from 9:30 to this. It generally function for say 1 or 2 hour daily, maybe, or maybe a couple of days in a week. So early morning uses are there. So the activity allocation is very much important, that those areas which are prone to more sun exposure, more solar heat gain, you can have some kind of activity which is not an extended activity. So you have to be very judicious in deciding the area location. So, and then you have some projection here, and then you have some projection here. There is a facility to give direct entrance to the first floor. You have a staircase facility, and you can directly enter to the first floor from the outside itself. So these are some of the things that you can note down. This is a very important thing. Means you don't want people to come from the ground floor. You give directly entrance exit from the first floor to the outside. That is tremendous idea, and that is uh, these things means you are if your building is a little bit, say if you are using say semi basement kind of a thing, then these things may function even better. So these are some of the architectural things I want to discuss in this building. Like this is what you have the western side, this ramp, which is responsible for curtailing heat gain through some of the western face of the building. Curved vertical fins to protect sun from low evening sun. So these are the curves. You will find these are the fins which has some curve, and I presume that they are designed as per the solar passive design. So they are able to cut the low angle sun. I have not seen any demonstration here, although we can create a model of this building. Even those people at that time who created this drawing may have done some kind of analysis. So these are the staircase provide buffer for the southern scene that I was talking about. Projected second floor. There is one thing that was, if you see, there was a stone cladding, gray stone cladding all over the building on all the corners, and this cladding actually failed aesthetically. Means uh, maybe some construction issue was there. So now these claddings have been removed and some different color has been used to have this. So workability in India is still a concern. If you are demonstrating such a fantastic design building and still the stone cladding falls every now and then, this becomes very risky if any student is there. So they have removed all the cladding after one in the previous few years. So that is the negative part of it. We should also talk not only the positive, we should also talk about the negative part. So these things need to be taken care of by just by simple innovative construction practices. These things can be stopped. Then you have a projecting entrance for shading, recessed entrance provided refuse from shade. So since this building will be used by thousands of students and there are offices of dean student welfare, dean student academics. There are then you have computer labs, you have committee rooms, you have offices. So thousands of people will be using this building. So there are refused. So there is always a shade in the lobby area. So if there is lobby that is closed on three side, one side it is open to the outside. So you have a good refuse area that refuse area is also responsible for creating some kind of barrier between the outside and the inside. So the inside corridor temperature is maintained quite effectively. Then that is again the covered fence and entrance porch. The glazing, usually a large number of low SSDC glazing solutions available. So reduction in SSDC is the prime most concern, and reduction in V also results in. But there is a problem. When you reduce solar heat gain coefficient, VLT also decreases. So this is a general phenomena. You cannot argue that. So you have to select a glazing type that has low SSGC but good VLT. Then only, so you have to find out the perfect optimum trade-off solution. If you go high VLT glass, SSGC will be increased. And other options are there. You can use blinds to curtail down solar heat gain. But in long run, you must go for, you have to go for some kind of trade-off between these two. And by hit and trial method, you can. And then in the software, you have complete glass inventory. So there are at least 500 types of glasses, whether it is single glazing, double glazing, triple glazing, glazing with air in between, or double glazing, triple glazing with argon in between, or krypton in between. So depending upon, so even in the equest glass library there are more than 700 type of glass already given. So depending upon it, you can use and see what is happening related to energy consumption aspect. So this is what they have gone with. U value was 1.9, SSCC was 0.28, VLT was 0.39. So this is what they have gone for it. And what I presume, if you have good enough shading devices, good enough fins, you could have gone for even better VLT, because direct sun ray will not be coming as you are designing a good shading devices. So SSGC, even if it is 0.35 or even if 0.4, but if VLT is again you have zero point 0.6, it would have been even more nicer. But for office building, you have to make some considerations, because yes, for schools, for classrooms, you need good VLT glass. This is office building, and office building you generally can say that okay, we don't need that much of daylight in comparison to the classrooms of the students, because in case of power failure or so, students needs daylight more. So yes, for office building, this use SSGC and VLT can be agreeable, but anybody can argue this, that if we have better glass, which is having an SSGC of even 0.31, but VLT of 0.45, I will go for that. Yes, you can go for that. So if better configuration is available, you can go for that. There is no problem. This is the wall section they have. Now, one more thing I want to describe it here is that since there is no architectural style in terms of shading device in the old building, which is of architectural importance. So what the designers do, they extend the second floor itself. So that's how the second floor is acting as a shading device for the first floor. So that has been extended. So that is again a very good initiative taken by the designers. And yes, for like this. So this is for the second floor. So second floor will become a shading device for the first floor, and then we have a ground floor. Yes. Now this is for a typical roof section. So mudcuff and inverted pots have been used, and this is again a typical roof section that has been used. Means you have a 75 mm insulation inside the building. Then you have RCC slab. So within there is a RCC slab. Then beneath it slab there is an insulation. Then you have inverted mud pots. Then 75 mm cement concrete. Then you have a cement mosaic tiles. So this is the configuration they have gone for it, and the U value of if it is mentioned somewhere, it will be written. So some innovative solutions they have done, and U value of the roof was found to be 0.35. That is tremendous, which is even lower than the core requirement at that time. So today this might be good enough for even ECBC plus or even super ECBC. If you just check from the ECBC latest code, 0.35 U value in a composite climate. Jaipur comes in composite climate. Just check. You can check and verify whether it is super ECBC or ECBC plus. These are the reasons. Lighting designs. Again, this lighting part we will take up in the next semester only. So you go through it. HVAC design again. The main thing was using the building. I will just give you some of the strategy. Now, this is a large building, and not every time all the sections of the buildings will be functioning. So they have devised a strategy like some part of the building will be used sometimes, another will be used at some other times. So they have taken up approximately 10 tonnage uh, devices, VRF devices, and they have zoned it beautifully. So this zoning aspect can also be looked in the EQS software. There is a complete that which part of the building you want to have air conditioning, which part you want to exclude it from air conditioning. So depending upon its the capacity of the zone will be the load of the zone will be found out, and the capacity of the HVAC device is decided. So instead of having a large HVAC system, we have small 10 ton or 9.6 ton to be precise, different units which are catering to the different zones. So depending upon the requirement, all these HVAC systems will be switched on. So this is again a very fantastic innovation that they have done. But for that, you need to know the complete uses of building, how the space will be used, when and how. So these questions are to be met. So when you are designing anything for, say, Indian Institute of Architecture building, you must completely know what are the activities going to happen in Indian Institute of Architects, room wise, block wise, floor wise, or vertical and horizontal zoning. So you should also know the vertical zoning. There may be possibility that there is a committee room, then you have a committee room again. So whole floor plate is empty, but the two committee rooms, one in ground, another in first floor, they are functioning, and there will be staircase nearby. It means all complete floors are empty, and only two these are functioning. So for these two committee rooms, you can have a specific HVAC zone, and there will be some HVAC centralized HVAC unit that is providing the air. So these strategies can only be known if you know the proper functioning of the building. So the zoning aspect becomes very much important. You should know each and every corner of your building, how this room will be used, for what purpose, and what will be the probable timings. If you know each and everything, then only you can design the best optimum HVAC layout. So that is your task to do. Then solar PV plant, you can go through it, and I will not take too much of go into detail because some of the aspects will cover in the next semester. And this is how at that time eQuest looks a little bit ugly. Now we have better interfaces and better building drawings in this. And then you will find the scheduling aspect. In the previous class, I told you that there are a lot of charts. In those charts, you need to give the timing of uses of building, of equipments, everything you have to define. So these are some of the this is the base case scenario, and this is the proposed case scenario. They are able to curtail out some of the energy. Space cooling and space heating was reduced. Space cooling was reduced considerably, specifically for the month of March and October. So they have shown that more than 30% can be saved, and this is for the saving aspect. These are the energy efficiency measures in terms of roof insulation, in terms of wall insulation. So they have not only gone for one energy efficiency measure. They have looked at least three aspects. Say for roof insulation, they have gone for 1 inch roof, one wall roof insulation. Then they have gone for 1.5 and 1.5 wall. Then they have gone for 2 inch. So they have simulated different scenarios. They have simulated different scenarios, and then they come up with some payback period and revised payback, and then they accepted, okay, that the first option should be more good, because ultimately it's the money thing. You If you have budget, if you have a fantastic budget, you can go for the best possible solution. But if there is a budgetary constraint, then out of these three things, you can find out, okay, this is good enough. Because even if the first thing is good enough, it is giving us the payback in 7.3 years, then you go for that. But 2 inch insulation will be costly, and the payback is 13 years. So you have to make again a trade-off. Which one is beneficial to you in terms of economics? So yes, economics is the most important part in when you are dealing with energy efficiency. You cannot simply blindly go for the best solution. If there is no money, how can you have the best solution? You should, in a technical report, you must give this is the best solution, this is the optimum solution, this is the little bit close to the optimum solution, and this is the base case scenario. So then you identify as far as the budgetary constraint, optimum is better, or even the best is, if you can purchase, you can purchase the best solution. So you go through this, and I will just show you all are the persons who are involved in this project. If I have the names here, uh, Maybe in the last page we will have the name. I will just look at the last page. MNIT team, project team. Mr. I.K. Bhatt was the director of MNIT at that time. Okay, so this is all. I think the team was constituting of, maybe in the front page, if I go to the front pages. Yes, the report, the author report is Jyotirmay sir, Sanjay Mathur. These are the mechanical engineers and the renowned scientist in MNIT. Then we have architecture department Tarush Chandra, and then this is our own alumni. And yes, these are some. I don't know these. Yuvraj Dhaka, I know. He's a faculty in MNIT itself, and is maybe some persons related to this Pacific Northwest National Laboratory and other things. Other persons I don't know. This was the first project. You must take a pride. Your alumni has worked in this, and you should go through this. And this work was done under when she was doing summer project. Earlier, we used to ask students to go for summer training of 2 months after completing the first year. Now this practice has been curbed, but earlier we used to have a fantastic exposure, and that was and in, like anyways now the system has changed, which I don't like. The main thing is the students should go and explore the world. Thank you very much for this, and you must download this document. You just take, you can copy the text here, energy conservation building code, and you just type on Google. The first document will be your this document. Yes. So anybody, I am stop sharing it. Okay. So I think uh, you will get more insight if you read this document carefully. Then you will get more and more insight what is the actually demand of the professional world nowadays from energy perspective from an architect. So if architect is willing to work in energy sector, these things are the minimum requirements they need to do. Yes. Any specific question, if it is related to today's lecture, you may ask, please. Yes. So first is you download this document, go through this document, and those who are very much keen in energy, and they should read it more elaborately. They should read it at depth. So thank you very much for attending the class.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.